Hello.
Hey.
Yeah, great. I can be heard and I can hear. Um, I'll just put a notification in the public channel. Okay, we're all here, so we can get started. EJ, you were, assume you were PTO last week when we met. It was kind of a ad hoc meeting too, where we had left off. I don't know if you're PTO or not. I know we just had an ad hoc meeting, and so
Right.
we just got started quickly on it. Where we had left off is really kind of on cogen, and Paul had said that possibly into this week he'd be getting very, very close. And that was kind of the only really blocker right now that we're looking at, and kind of the focus. So I'll hand it off to you, BJ, but I think we should start with Paul.
Yeah, I'm fine with that. Paul, you want to give us an update on CodeGen?
Sure. I pretty much have what I need in place, but I do need something from Hans, or at least need to work with Hans on getting something in place. I found an issue yesterday. Well, it's basically a blocker for me at the moment, but as for how I'm going to work around it, it's either, there's two different ways to approach it. So I need to talk with Hans about what he thinks on that. But bottom line is that everything for like the basic lowering kind of that we talked about last week is in place. So what I was running last night was basically compiling a file and seeing where things blow up, and realized that that was when I found that thing that I had missed or overlooked anyways. Bottom line there is that the block arguments and the EIR IR are not passed along to uses or to successor blocks. So what that means is that when I'm lowering into LLVM, MLIR, none of the arguments that I'm mapping back into EIR have clear, like, parents' origins. The way that block arguments are represented in those IRs are explicit. So there's no way for me to cleanly map them. So I need a pass that maps, or basically passes all block arguments explicitly to their uses, including transiently through blocks that are maybe not using those arguments directly, but calling blocks which are using them. That pass probably can just be part of the lowering pass or analysis, but that's something that definitely needs to be done as part of lowering. And I've been trying to avoid basically translating the graph as it is in EIR into C++ to work with it there, and instead just trying to pass only the data across the FFI that I absolutely need. So the approach is either doing this in EIR using the pass framework that Hans has been using for other things, assuming that that's viable. Otherwise, I'll have to map EIR a little bit more richly in C++ and translate it into a way that allows me to do that lowering as part of the translation I'm already doing for EIR into MLIR.
I'm a little bit, sorry if I'm interrupting. Maybe, yeah, we should probably take this afterwards though.
Yeah, sure. I was gonna say, can you guys, Hans, do you have availability after this call? Just
yeah, that's fine with me. Let's do it afterwards.
Okay. Is that
but with that in place, then pretty much all the dependencies that I needed for being able to compile some simple programs would be there. So that's really the main thing standing. You know, the work that I've done now that comes through before I hit this issue indicates to me that things are being translated the way they should be. So that means that barring any unforeseen issues, like once I have that pass in place, the rest of that compilation should proceed without error. And we'd have some output that we can then run some tests with. I set things up on my local branches of things so that I can link against, well, there's two things, and probably Luke will be interested in this part. There's now like a core runtime shim that handles like the very early stage initialization for all platforms. This is the part that takes over essentially like the start and main for from Rust. But then there's also a macro now that allows you to decorate in a particular runtime crate which function is like the main for Erlang. So with right now it's just using Lumen Web and Lumen Runtime as the two runtime crates. But in both of those now I've set it up so that there is an appropriate function decorated as the entry point. And then that would be automatically invoked on startup for both of those platforms. Where Lumen Runtime represents anything that's not WebAssembly, Lumen Web represents WebAssembly. So that framework provides like basically a uniform way to kick off like the startup of the program in a way that allows us to not have to replicate that code everywhere. And I can go into more detail with that at another time, but that part is also now in place, as well as the linking steps needed to link not only that runtime in, but also a generated module holding the atom table with all the atoms collected at startup so that that gets seeded correctly, which also involves some small changes to libeir intern to make sure that the predefined symbols actually map in a way so that I can use this trick to use false and true the way that I'm using them during lowering. And then last piece of that is linking in the runtime, which it also now does. So all those pieces are just waiting for an object file or set of object files to link against. So hopefully with that pass, then we can actually put all that together and see what we get.
Cool. Questions from anybody?
For the WebAssembly side, is it enough that like it works because you're able to run it in a browser, or just you did the same thing you did to the x86, so you're pretty sure it will work?
I'm not sure I follow. What do you mean?
Well, you said you made a decorator that works to do the start functions both for the web and for native-ish targets.
Mm-hmm.
But does that mean that you actually have it where it can boot in a browser, or is it more just okay?
Yeah, it's basically a matter of passing the right linking flags to like when you're compiling the WebAssembly module to specify the entry point that acts as like that shim.
No, I get that, but have you actually like with the compiler web works already? That's what I'm asking.
Oh,
like,
no, I haven't linked
okay.
together an Erlang module and tested that yet. If I could
Okay.
do that, then we'd already be where we want to be, but we're not.
Okay. Well,
I mean, I could probably write like a MLIR version of some Erlang code and then compile that and link that because that part of the compiler works. But without the pass I was talking about, I don't have a way to map like Erlang source into an executable.
Okay, I didn't know if you like somehow made a WASM module that adds 1 + 1 = 2, even if you can't like print it to the console, but like you knew.
Oh yeah, no, I had already done that. I haven't
Okay.
tried like loading it up in a browser, but there's no reason to believe that it wouldn't work. But I could certainly test that.
Okay.
That aspect of it. I already have like some testing on our modules I was using, testing all of the cogen stuff, including linking. And it was basically, yeah, doing something like that.
Okay.
In my case, I was actually on testing on x86-64, just linked in libc and had like a print function that just did like a recursive loop. So I was just testing that, but I haven't tested that in WebAssembly yet. But.
Okay. Right now, do you think it's more likely I can demo in Brussels at FOSDEM native, or do you think we can still potentially get spawn chain to work in the weeks we have left?
I mean, that really depends here on getting this pass I was talking about done quickly. And it's fairly simple, the transformation I have in mind. So the main thing is just making that happen. Hans would have a better idea than me how long a pass like that would take to write, but with that in place, we'd have all of our real core dependencies needed, and could start sort of working on the spawn chain part of it in parallel with kind of finishing out sort of the rest of the unimplemented features in the compiler. What's the timeline on that? That's like a month from now, right?
It's the 1st of February.
1st of February, so a little less than a month.
Yeah. Mind you, it's a shorter talk, so like I also can't.
For spawn chain, I think that we should be
before,
able to make that happen. Yeah.
Okay.
Yeah,
like we don't need it where anyone can do spawn chain, like because like anything that is better than Luke Mechanical Turks to port the source code, like.
Yeah, I mean anybody would be able to do it at this point, right? Like if the compiler works well enough to be able to generate the spawn chain demo, then anybody could write something using the same combination of primitives that the compiler supports. Right. So
like I'm okay if it's multiple steps, sort of like how the interpreter currently is multiple steps. It doesn't have to be a polished single Lumen command and it just works.
That part is already done. So
okay.
That's not a thing that we need to implement now. That's already been implemented. So the only thing that needs to happen is to have enough of the core operations supported so that all the syntax that you're using in the spawn chain works. And I guess there's the aspect of it that is getting Elixir source code lowered in Erlang and then fed into the compiler. But
I'd be okay with running in Erlang. It's Erlang / Elixir. It's a combined track at FOSDEM, so like it doesn't have to be an Elixir.
The translation into Erlang is like the least interesting part anyways. Writing it in Erlang is sufficient to demonstrate everything we're trying to demonstrate right now. But I think the Elixir part is already done. Hans already did that, I think. So
yeah, it's just plumbing.
Okay.
But yeah, I would plan on being able to do that demo using the compiler for FOSDEM. I don't think there's any reason why we would not be able to have that much ready by then, even with some manual steps possibly. I'm not sure exactly what manual steps would really be required at this stage, but maybe it would be having to manually like tie together the JavaScript shim and stuff, to actually load it up in a browser. Assuming you're not just like running it on the server or something like x86-64.
I mean, both options are doable. Obviously, we've been trying to target that web was first, but if we can do x86 but we can't do web, I'm fine with showing x86.
Yeah, be mostly because the pieces that would not necessarily be at all in place yet are the automatic generation of like I'll call it like the cradle, right? This package that has like the JavaScript file and maybe like an HTML file and things like that. So you can just easily run the thing that you've just created.
I think that really falls down to whether, if we're able to still use WASMPack build, we can ignore that. But if like we end up being not compatible with whatever WASMPack build wants to do,
I guess it depends on what WASMPack build wants, right? If it's expecting to compile the current crate and generate something from that, then no. that won't work. If there's a way for us to say, I've already compiled the WASM module, here's some metadata, do the rest of it, then we'd be fine. I think in reality, we're probably going to have to generate our own version of that, which most of what WASM-Pack build, I don't think, does is particularly interesting to us. The parts that are interesting are what goes into generating the JavaScript shim.
Yeah,
all the interop stuff.
I'm assuming the WASM-Pack build is the part that's extracting out those extra sections.
Yeah.
From WASM bindgen, and like, one is stripping them out in the final WASM, but two, using them to produce the JavaScript. So we would need something. We can either mimic exactly what they did, which seems kind of silly, or we can also
I don't think we need to
do something similar.
I already have infrastructure in place now in the compiler to carry around all the metadata about the compiled project, if you will. So, for example, two of the things that I store in there are the entire atom table that I've generated during compilation. So all the different modules that are being compiled are happening on a thread pool, but as those modules are compiling, they're gathering up any constant of any kind, really, but of interest is atoms, right? So any of the atoms that are found that are constant values in the compiled modules are stored in a big hash set, which I then dump into a generated LLVM module, which has all the infrastructure for linking that stuff up at runtime. But the other thing I have in there is all the function symbols. So that's mostly I'm holding on to that now just in case I need it, because I have a feeling that that's going to come in handy as soon as we run into like dead code elimination and we're trying to figure out which symbols we need to preserve or not. But in any case, I have a symbol table of all the functions that have been generated. Another aspect of metadata like that we could store then would be all the types that we've encountered, or functions that are calling JS API that have types that we need to generate some sort of interop thing for. We could use that metadata then to just generate whatever we need to work with either WASM bindgen or our own version of that, or to generate JavaScript code ourselves. I don't know exactly how we want to approach that, but my feeling is that we're much better off trying to sort of pick and choose the things that we can use from WASM bindgen and WASM-Pack and use them ourselves rather than try and force ourselves to use the path that they've gone down, because I think that there's not actually a lot that we can reuse effectively there. You know, early on, maybe we could do something like generate custom sections, especially for WebAssembly to make that stuff work.
Well,
but I'm
right
not sure
now,
if that's profitable.
Can we spit out a Rust lib style thing out of the Lumen compiler so that we could?
Well, an rlib is just literally a static archive with some extra metadata stashed in there.
Okay, because I was just thinking if that's the case, then because there'd still be that the librs in the spawn chain example where it has the three functions that are like the interface functions that use bindgen, but then the rest of the code could be the code generated from the normal Lumen compiler, and that would get us around the problem of, because there, like all the other code is already bindgended correctly, and it doesn't matter because like Lumen Web's already compiled the way it wants to be compiled.
Right.
And so it's really those three functions and the actual, start call that matters. And that would get us over the hump that we don't have a way right now with attributes or any other sort of metaprogramming to specify these functions are callable from JS. And so we could still leave that librs, but call the rest of the code if it was in a format that could be called by it.
Which librs are you talking about again?
The one inside of example spawn chain has three WASM bindgen functions in it. So if you go into spawn chain source librs, there's bindgen start, which we have to have no matter what, which you probably are already doing for us with the new stuff. But there's bindgen on run, bindgen on log to council, and bindgen log to dom. And those are the three that are callable from the council. And that's what we kind of need WAS Impact to do to generate the JS for. Because that's the stuff
those
that's
would be, yeah, I think probably what we could do is move that stuff, or whichever of these we need, into Lumen Web or into a WebAssembly platform crate. Because like log to console, for example,
log to council isn't a generic log to council. It is doing the spawn chain demo, but outputting it at the council. So it is very specific to that application.
I see what you're saying. It's just calling run with output, right?
Right, because the way this thing generates, it generates a module named after your thing. So that actually in JS is called chain.log to council. So it's not the generic log to council web API.
Yeah, so I mean, like, for example, with the spawn chain demo, if it's coming from Erlang source code, like none of this exists in Rust, right? Like basically the only thing that exists is the start aspect of it, but like the run, log to console, log to DOM stuff, that's all implicit by using runtime functions, right? Like writing stuff to the console or whatever.
The iffy one is the wait with return, which is the one where like it starts up a process, but it's unscheduled. And like we don't have an Erlang equivalent of that right now. So that's the run with output in that same file. That's the one that does the magic part of like.
You said it spawns a process, but it's not scheduled?
Right, because the reason for that is you need to have two frames on the stack. When it does that, it does the frame of like, I'm going to return to JS with a future. And then the other one is once that frame is there, it does the frame of like the actual work that's going to have a return value, like a normal function. And it's that frame at the bottom is special because when it runs out, instead of the process just exiting, it first sees, oh, I have an executor which contains that JS promise, and I'm going to put the like return value from the last Erlang function into the promise to make the JS promise finish. And that's how all those functions are talking, because all those are, if you look at the signature for run, log to console, log to DOM, they return a JS sys promise because they're all AC functions from JavaScript's perspective.
But none of the, so if I understand correctly, none of this is using the Erlang scheduler at all.
So what? No, it does. So the spawn, what does is it makes a process. That's where you have the block where it has the child process on line 60, and then you add on that extra frame of like the actual work of the process, and the child process already has the like the promise inside of it at that point.
Right.
And then once that returns at the end of the unwrap is the promise it is now scheduled. So by the time the spawn function returns, if unwrap succeeds, then it is already on the scheduler.
Okay.
And actually running, and the scheduler is always running because the request animation frame loop.
Right.
And so this is necessary because the request animation loop is always doing stuff. So you can't schedule the child process because it'd be kind of racy to be like, I'm going to create a process and hope that I can put on the frame that actually does work before it tries to return to the promise.
I'm just trying to think here.
There would probably be a way to write this in Erlang. It would just be...
Well, I mean, we definitely... obviously, we need to make sure that this kind of stuff is generalized so that we have whatever runtime support we need to be able to do the things that we have to do. I guess the part that is catching me up and maybe I'm missing something, is that just placing, like, we're just spawning processes, and I'm not sure why each process here, why each process would be returning a promise to JavaScript.
Because they have to be async. Or what do you mean?
Like, so
Like why the
here's what I
processes keep
mean.
running
Like,
like a gem server?
each process that gets started would be started through the scheduler. Any work that it does interop with the like DOM or any JS APIs, for example, would essentially have to coordinate with the scheduler for that work. Because obviously they'd be blocking on a promise, so they shouldn't be scheduled if they're waiting on a promise to be fulfilled.
No. This isn't us waiting from a promise from JS. This is JS. This is us giving a promise to JS, because these are all called by the user.
Yeah, I know.
Okay.
I was talking about the other way around, where I don't understand why we're returning a promise to JavaScript for spawning a process when there's nothing barring us from spawning a process into the scheduler, even though the scheduler may have yielded to JavaScript this is still shared memory. Like, there's nothing barring us from working with the memory of the process or of the scheduler, including doing stuff like obtaining a lock to be able to spawn a process.
This was mostly safety for not putting it in the queue, because I would have to reach deep into like grab the locks for each scheduler, and this way I don't have to know about the schedulers, like, until I want to do the work. Otherwise, I'd have to block them doing work. And this was more to proof it if we ended up doing the web worker stuff later. This way, we only hold the lock for the minimal amount of time to actually put the process on the scheduler, as opposed to the entire time we're computing the 2 frames, which I know isn't a lot of time, but we do these sort of optimizations all the time. So,
well, you'd only have to obtain a lock for the current scheduler or current threads scheduler. So since you're on the same thread, there's no contention there, right? I mean, the only thing you're potentially blocking is like another thread trying to communicate with this one, but it's not going to do anything anyways, because there's a way for the scheduler to have control again. At least if I'm understanding this correctly. I guess the bigger problem, of course, is that we ultimately need to allow the scheduler to be driving this sort of interaction, because from the point of view of writing Elixir code or Erlang code, none of this is surfaced. None of it is a thing that you even would be thinking about. And so we need to, generate code normally, and then rely on the scheduler to handle this sort of interaction, right?
right, that's my point. We don't have a way to write this. We didn't come up with an attribute system to tag stuff, the equivalent of WAS and bindgen. And that's why I'm saying that if we don't have that, if we just use the librs, then it'll still work, and I can demo it the same way. Otherwise, you need a way to have JavaScript async functions, because if log to DOM is not async, what happens, and I have videos showing this, is yes, it works, but it pops at the end. So if you say spawn, 60,000 processes, yes, it works. It generates the table. The table does not show up until the end because it is stuck and not yielding the entire time.
Right, but log to DOM is being called from JavaScript.
Yeah.
I'm not talking about calling things from JavaScript. Like, that's not the important way of interacting with this. Like, when the only thing that's going to happen when a page loads up is that either explicitly one says start this application, or it automatically starts depending on how you set up your HTML. But either way, you're not explicitly calling functions to drive things happening in the WASM module. Maybe in the future that would be the goal here, but the idea is that these WebAssembly modules are the core application that you've built. So there's no need to be calling these functions. The function that gets called like this is the scheduler entry point, or really, well, not the scheduler per se, but
I just want to plug in for a second. We are on the free tier, so we have a time limit for the meeting as far as Zoom goes. So we're 40. I think we're at 30 minutes right now. We have another 10 minutes remaining in the meeting.
It just sent me a message saying you upgraded it, so it might have already decided to give us more time.
Yeah,
I upgraded it. What?
It said the host upgraded it.
Yeah.
What? It upgraded.
Just now it said the host just upgraded this.
Maybe it just automatically did it for some reason.
I mean, Paul, I agree that I agree that, like, yeah, having things you call from the council won't happen a lot, but this is how the demo works now because we didn't really have a DOM interaction story except for the little thing I hacked together. So
I mean, we don't need to make it work that way. What we can do for the spawn chain demo in this scenario, and with, I'm not talking about the existing one, I'm talking about porting it to a new compiler, is that on start, the main process that gets called, or the main function that gets called, it just kicks right off into the spawn chain. There's no need to explicitly call a function to start that chain.
I agree that's the way to write the demo. I think it's less impressive because you can't change the values. It's a more limited demo. It's not the same. Yes, we can do that if that's all we can pull off, but that's not.
Well, I mean, a way to adapt that, I guess, would be to explicitly call the application entry point with a different set of arguments. So one of the things that we can handle is arguments in the sense of configuration, whatever we want to make those arguments look like. It really just boils down to what our entry point looks like. You currently do things that are
with the JS bindings. That's why I said to use the WASM pack and this lib thing. Like, I understand we can't do that yet because we didn't think of a way to do what WASM bindgen does. And that's why I was proposing letting those shims stay there, but they would, so the part where it says like none placed with arguments, it would instead would call whatever thing is exported by the Lumen compiler itself. But it has to have like a signature that we can FFI for that to work, of course. And I didn't know if that was possible. That's pretty much what I was asking.
Well, the signature in this case is a generic start that can receive whatever arguments we care to give it. And by receiving arguments, I don't necessarily mean like literally taking them as function arguments. It can be pulling something from the JavaScript environment by calling a host function, whatever needs to happen there to initialize some base configuration. I mean, that kind of thing is already going to have to exist to some degree because you need a way to initialize the application with some base config, just like you do on any other platform. You know, in the case of things like vm.args or the .config files. Obviously, those don't exist in the browser, but you need a replacement for that sort of initial configuration file. And my assumption is that people will naturally want to use like a JavaScript object to represent that. So making sure that our WebAssembly entry point understands that and uses WASM bindgen for that allows us to not have to have a bunch of like application specific WASM bindgen functions like this.
Okay, but are you saying the entry point can be called multiple times, or it's literally
yes,
you call it once?
On WebAssembly, not on any other platform, but yeah, WebAssembly can be called multiple times.
So what does that mean when, so you're going to have the start function and you're going to have one export function is the way to think about it. Because the start function has to run to have the schedule and request animation frame, but then you're also going to have a single entry point that takes kind of like an object-y thing so that we can say who to call and it will figure out.
No, just one thing, just one function. Before we ever kick off the scheduler, we can decide what we want to do before we call that function, including pulling stuff out of the environment, performing some initialization or setup. Like that's in Rust. So we can do whatever we need to do there, and then use that to basically set up the environment, and then you call the entry point that kicks off the actual startup of the program,
Okay.
the scheduler.
I mean, that's fine. We'll eventually need this sort of bindgen thing because this would cover the story of we can call in from JS into it, because if what I'm saying is, like, it would be the same way where like code needs to give feedback to our app and it's already running. Like, you need to be able to do this sort of thing where you can call in and the scheduler is already running because you're running other stuff in the app. Like, it is actively talking to the server. If
calling into the running application from JavaScript later on, or like in general, is obviously an important feature. But way back when we started talking about this, we had explicitly said that that was basically a feature that we didn't care about for the very first version of this. That the assumption would be that this is a self-contained module that does everything it needs to do inside itself. Once it starts, it's self-contained. And that calling in like external FFI basically would be a thing that we would approach as the second phase of that. We obviously need WASM bindgen for just generating our bindings for the things that we consume already from the runtime. But as far as application, like user application specific bindings, like that was explicitly a thing that was going to come at a separate stage of this.
Okay,
so
that's fine
why
if we want to just drop the spawn chain down to like that, because realistically, like, we don't depend on like the two things working at the same time. Like, nothing I showed depends on that. It'll just,
right.
What I do in the console will change. As long as that one entry point is callable from the console with the JS object, that's good enough. Yeah, because like the one that's actually hooked up to the web is Lumen Web Start, and that's like a thing I just put in Lumen Web Start where it automatically hooks into the data properties and the on events. So that'll just be in all of them for now.
Right,
So
and
that's separate.
that's essentially like that core runtime shim that I mentioned earlier in the call. Right now, it's calling that entry point that you set up in Lumen Web.
And later on, when we have real frameworks, those will be in the hopefully normal OTP application start stuff where they would do that. So that'll work for now, and that would get rid of the, if we can just pass like a JavaScript string or a JavaScript symbol that has the word run or log to console and the count value, that would replace the 3 WASM bindgen functions that we need right now.
Yeah, I mean, we can make that interface whatever we want it to be to make it work. I think trying to take an approach of making it general enough that it can be used for more than just the spawn chain makes sense. And by general, I mean, like, make it take a JavaScript object that we then transform into the argument list.
Oh yeah, I would just make it be MFA is what I would do. But
the way you want to take it is in the same way that you would sort of treat an argument array passed to the main Erlang executable, just like a custom set of flags, right? It doesn't have to be a flag per se. The idea is that you're just transforming it into that representation so that from the Erlang code, all you're really caring about is like, give me the start arguments, and then I'm going to map that to whatever I want to do.
Well, yeah, Erlang has support for an MFA style invocation, like one where it's not a string script. So we can just say we're doing that, and it'll look the same then. So
yeah, exactly. And then the nice thing about having that as sort of that foundation there is that then when people want to download, start playing with Lumen, they have that as like a thing that they can use.
So the one gotcha with that though is if you don't return a promise, you're not going to go back to the JavaScript event loop, and the DOM demo is still going to pop.
Well, no, the way the entry point works now is that it kicks off the same way that the Lumen Web thing kicks off, which is to use request animation frame.
Okay, so the only difference would be before we do request animation frame, we would queue up one process with our MFA.
Right, you'd set up like those init arguments and then set up your init process and then kick off the scheduler, which uses the request animation frame to drive the normal scheduler loop.
Okay, that would work.
And that init process will be like, we're going to need this anyways. I was already digging into this a little bit to figure out like how far we are from having some of the more normal Erlang startup process in place. And aside from like mapping the information we have at compile time into like a boot script kind of instruction set, the main thing we need is like that init process that knows how to start up things in chain, right? So figuring out like, okay, we need the init process that does like whatever initialization is necessary, then starts the application controller, which then starts the first application, the first process in that application, and so on. So that will be a thing that we'll also need to do. But I think for the very first version of this, we can just say, fuck it, start an init process that does the main function of the Erlang code or Elixir code that's being compiled, and call it good.
Yeah, as far as I can tell from the demo, the way I wrote it, it shouldn't require applications to be running in the background, because
No,
like the
I
processing
don't
I
think
use
so.
don't use any background processes. Like
Yeah, it's
Beam it
using
would,
just
but
raw
mine doesn't.
primitives, none of the OTP stuff. And so really what I'm talking about there is more OTP in nature, but we can get away without that, at least for the initial couple weeks of this. But I think that would be obviously the next major priority, is making sure that we get that into place, because without that, a bunch of stuff doesn't work out of the box. So.
Yeah, we won't be able to use normal hex packages that expect
Right.
to have an application tree.
Yeah, so, or compile Elixir for that matter.
Yeah.
So to recap, I think we basically already have everything that we just talked about in place. The only thing that we probably would need to do then is just figure out how we want that, like how we want to call like the start function with, say, a JavaScript object or whatever makes sense that contains like the initial configuration, which we can then just treat the same way that Erlang treats like its vm.args file. And then have one of those flags be like the start function to use or whatever, like the -s flag. And yeah, then there's the pass that we need so that I can finish the cogen. But with that, I will just test straight away using more or less a naive little program that I wrote that just does like a couple recursive loops and does some printing, because that is simple enough for me to analyze like the IR and everything pretty easily without it being absurdly large, and does something non-trivial enough printing that it doesn't just get code-genned away. So I think realistically speaking, assuming that that pass is like a 2 or 3 day thing, we might be able to have like a very primitive release of this next week.
Do you have
I guess
test
it really
cases?
depends.
Do you have test cases for receive with wait, where like the receive doesn't immediately work?
I mean, I don't have test cases for those because I don't have an executable to write tests against.
Okay. I didn't know if you did it the way you're doing the other stuff.
Yeah, I mean, the way that the testing is going to work is there's sort of 2 or 3 different classes of tests. One is the set of tests that is testing that the transformations happening in the IR are correct or doing things that we expect it to do. The second is making sure that the LVM IR that gets generated matches what we're expecting the lowerings of various things to be. And then the final set are unit tests / integration, more like integration tests, which actually run the compiler to produce an executable and then test that executable doing something. I guess there might also be like a 4th class, which is tests which test some behavior of the executable. But that probably is going to require some instrumentation that I'm not exactly sure how we're going to want to approach that. That's more like running like an Erlang test suite that can sort of surface things that we know are problems because of what happens in the test when they fail. So an example would be like if there's something wrong with the way receives work, then presumably the test suite, if it was written in Erlang, would fail like explosively for that because it's such a primitive operation. But we probably know well before we even run a compiled executable that there's something wrong just based on the IR that we generate. And that's going to be something that we'll all have to kind of examine together, like how we want to set up a framework for testing things all throughout the compiler in such a way that we can verify the things that are important to verify without having just an enormous amount of tests to maintain by hand every time we're making changes, or if one of our dependencies changes in a way that changes the IR. LVM is really good about how they handle that, and so I'm planning to more or less follow their lead on like the IR testing front. But testing the executables is something I'm less sure about. I haven't looked too deeply into how LVM is doing that right now. But you know, every compiler is a little bit different in that regard, I think. So we'll also have to have our own guidelines. So yeah.
So I have another meeting that I have to jump to. We didn't really get a chance to talk much to Brian or Hans about what they're doing, although Hans, it sounds like your next priority is going to be helping Paul. Do you want to give a quick update, Brian or Hans, on what you guys have been up to, or?
I'll go since I'm about to have to leave too. But basically, so I saw that that PR I had was merged, and so now when I get some more free time, I'm either going to work on more time-related APIs, or and then when the compiler is ready, I'm going to go back over to the work on the Elixir compiler and look into that some more and try to hook that up. But that's about it. No, I'll talk to you later.
Thanks, Brian.
Thanks, Brian. Talk to you soon.
I've been working on redoing the printer for the IR so that it's like fully customizable with annotations and stuff. And I also, apparently the guy who maintains hash brown is willing to accept the PR that parameterizes it over allocators.
Nice.
So I have something thrown together for that. And also a little update. I talked to Alex about this, but like the thing with my wrists have been flaring up a little bit. So I need to be very careful and take frequent breaks when I'm working, which means that it's difficult to get into like a flow state for me, which is kind of annoying. But I need to like be careful with it so it doesn't get worse.
Yeah. Well, I mean, with regards to like the pass that we need to write, I mean, I can do the mechanical writing of it, but yeah. I'll definitely need, you know, to talk with you through just how we're going to approach it in general.
We need to talk about the details because I'm a bit unsure about some things, but it shouldn't be that much work, probably, regardless.
Yeah, I kind of like mapped out what I know the translation would need to be naively, and I think it's fairly trivial, like graph traversal. So the main thing is whether or not there's, you know, like API limitations and how the pass framework and stuff works right now.
So
or
I'm a bit like, what was the actual issue you were talking about? Because I mean, at least I don't know about MLIR, but at least LVMIR, you can define values in like dominating blocks, and you can still access them in like downstream blocks.
Yes, and the way you have to do that is, well, you have to define phi's for those, so you have a similar kind of problem. But regardless, I'm not lowering directly to LVMIR anyways.
So
I'm lowering to MLIR.
So in MLIR, you have to define all
block
values
arguments
explicitly.
Are explicit, yes. because it's important for the way the transformations and stuff are applied.
So that's a difference from LLVM then.
Yes.
Okay, that's weird. But I mean, you should be able to just like
you can use block arguments for dominating regions in MLIR. I don't know how familiar you are with their terminology, but there's a few extra terms that they use. That would be like enclosing regions. So a module is a region, a function is a region, and then within a function you have multiple blocks. Each operation may or may not have regions associated with it. So if you're talking within the context of a block, it can access any arguments or any block arguments from its own arguments or from enclosing blocks, but not sibling blocks. And that's where the problem lies here, is that in most of these cases, these blocks are siblings. They're all children of a function. There's no nesting relationship with the blocks there, so I can't reach up and grab a block argument from some enclosing region. There is no enclosing region to reach to.
Is this a problem that the blocks are siblings, but they really, because they're defining new variables, they really should be like nested lets for all
no, they don't. It's fine that they're siblings. The difference here is just more of a semantic choice in an IR. So as Hans mentioned, LVM IR is a little bit different than EIR, but in both cases, they sort of have a sea of nodes thing going on. EIR is more flexible. LVM IR is more specifically allowing you only to reach block arguments from dominating blocks. And maybe that's a rule that more or less is effectively in place in EIR. But what it means is that any block argument you call, as long as it's up the chain from you, so to speak, is reachable within the current block. You don't have to take it as an argument or in some way reference it. In MLIR, anytime you enter a block, the only things reachable from that block are the arguments that it received. Think of a block in MLIR sort of like a function, in the sense that arguments to that block are, it's strict in that it requests you to only use arguments that you received to that block or from an enclosing scope, which is really only applicable within operations in MLIR.
So I'm gonna jump you guys. I'll talk to you guys next week.
Bye-bye.
See ya.
So to think about a solution here, it sounds like what you need. I mean, it sounds like in EIR you can't really. Calling like the if operation in EIR, right? That requires the 2 or 3 different branches to take no arguments, because like the block call is part of the operation. So
in MLIR, we can pass arguments to blocks that we're passing as arguments to an operation.
Yes, and
so
you're required to do that. Yeah. So then it would not make sense. I mean, we can't at least trivially represent that pass on EIR because the semantics are different in that way. But you have all the data you need, like in the live, in the lower utils calculation, there is a live set for all.
Well, wait. So with the example you just provided me, the if operation.
Yep.
There's 2 things. One, that operation takes just the blocks. It doesn't specify any arguments that it takes. However, I already know what block arguments those blocks take. So semantically speaking, if we know that an if operation is passing along some specific set of arguments, like a match, for example, has those implicit arguments that are a result of some of the branch or the match kinds.
Yeah.
However, we also know from the scope, given this transformation is in place, if the only SSA variables, whatever you want to call them, are within the current block scope, and we know that this block here receive some arguments that come from that block in the earlier transformation phase before we've done this lowering. We can map those arguments through. The problem is that I don't, I guess there is the issue of how do we represent that in the IR before when it gets to me. Shit.
Yeah, but you have like in the lower utils data, you have like information of values that are live at any point in the IR. So using that, like generating a, I mean, I can even do it in lower utils, but I don't think it would make sense to do it there. Just generate like a mapping, like from this blocks, these values need to be passed down. And then in this block, these IR values, EIR map to these ones added in MLIR, but that's a pretty trivial transformation.
That's interesting. Yeah, when I was doing some lowering yesterday, I was never seeing any live values, even though there was arguments taking blocks taking arguments. Yeah, in all these cases, the block has 0 live values.
If that's the case, then something is wrong there. And I'll look into that, but the live values pass definitely, like, that's solid because that's used for a lot of the other passes that I do. But then there has to be something in low utils, which is like a really small thing. I'll look into it. I can like look at it quickly right now, see if there's anything that pops out to me.
Yeah, I mean, we'll probably have to spend some time talking through this with some specific examples and try and see if we can suss out the right way to work with this. I know that right now, my lowering breaks because when I am generating, say, a function call, just as an argument, that function call takes values which map to block arguments. Now, the way I'm lowering into MLIR, I try and do it as close to the way EIR is represented as possible, and then I have a separate transformation that does lowering from there in MLIR. The problem is I'm trying to map values and blocks back to, so I have like their representation in MLIR and in EIR. So when I enter a function that I'm generating, I generate all of its blocks. And then I'm able to jump between them and map block references to the MLIR blocks. Likewise, each of the values that I lower within a block, I also have that mapping in place. I know that a particular value in EIR maps to this value in MLIR.
Yeah.
And then the problem I hit, though, is that when I'm mapping a block argument, like a argument to an operation like a function call that maps to a block argument from some other block, that's where it falls apart because there's no way for me to make that mapping in MLIR.
So, I mean, what you could do then is you have the, at least in theory, if everything works properly, and again, I'll like make sure it does, then you have the set of live values at every block. So then you know which values you need to pass on to like successor blocks from any given block. And then you can just generate a map of like pairs of this block and this value maps to this block argument. Right?
Yeah, sure. I got you. Yeah, as long as I know which values, which values to pass from the current block to its successors.
Yep.
Then everything maps cleanly. The only problem I hit is when I'm within a block and I realize I need to reach back up to a dominating block.
Yeah, but that shouldn't happen because every value that is needed should be in the live value set for that block. You shouldn't need to reach up.
I guess that's where I hit an issue. So the one I'm looking at right now, where did it blow up? Blow it up mapping value there. 55. That doesn't seem right. Oh, right. Yeah, I was trying to reach this, I guess. Yeah, I'll take a look and make sure that I'm dumping the left set at the right place here. If it still looks like it's empty when it shouldn't be, then
So
I'll probably have to get a hold of you again with a more concrete example off the top of my head.
yeah, where are you? Are you getting the? Are you using the live
from the
value
analysis?
Lower utils? Yeah.
Yes.
Yeah. And then there is live in and there's live at, which is if the value should be live at the beginning of the block, or if it should be live like after the operation executes. So there's two different.
Live at is at the current point in the block, or at the current block.
let me just open it so I remember and make sure I remember correctly. Yeah, so there's values that need to exist like before the arguments are applied, like at the entirely top of the block before
before you
block
actually enter the block.
Yep. Yeah. And then there is live in, which is after the block argument, which also includes what's needed for the operation within.
So live in, can you say the last little bit? I'm just writing this down so I don't forget it.
So it's basically before the block arguments are applied and after the block arguments are applied. What are live of those? Because the reason why there's two of those is that since there are some implicit arguments that need to exist that might not like be actually used, that's like a simple way of checking if a block argument that may be implicit from the calling block.
Like it allows you to differentiate whether it's dead or not. You know that it's required to be passed, but it might be dead in that block.
Right. Yeah. Exactly.
Okay.
So
live in would always exist in the live in set if it came from a successor and is used in a child.
If it came from a successor or in the current block arguments.
Came from a dominating block and is going to a successor block. Like it basically
or is used in the current.
Right. Yeah. I'm talking more about the case of like, it's not used in the current block. So it's dead in the, I mean, it's not actually dead, but dead in the current block and is used in a successor block, then it should be considered live within that block too. Shit, I think we lost him. Oh, you're there? Okay.
Yeah, it's back. Yeah.
So just to recap, like as long as, like in the case of it's not used in the current block, but is used in a successor, comes from a dominator, it's still considered live within that block, that intermediate block.
Can you repeat?
So I'm particularly curious about the case where you have some value coming from a dominating block that is used in a successor block, but is not used in the current block, but it transits that block, if that makes sense. Is it considered live for that block as well?
Yes.
Okay. That's the only thing I want to make sure
that passes through. That holds. Yeah. So that's what's critical for your for your problem.
Right.
Yeah. So using that information, you should be able to represent, like easily generate that mapping relatively easily at least.
Maybe the problem then is that I'm trying to reference the block arguments without going into the live set for them. My intuition was that if I just mapped all of them, like there might be some dead values in there, but that would not be a problem. They would get eliminated. But it sounds like the metadata around what is live or live in or live at is also important as far as generating that block argument.
I wasn't aware that MLIR worked in that way compared to LLVM-IR.
Yeah, it's one of the
It,
things that, like, they're a much more flexible IR, but as part of that, they're also imposing some new sort of semantics on top, right? So they're much closer to Thorin than they are LLVM, in the sense that it's basically similar to EIR, except for, you know, there's not the idea of continuations necessarily, but, you know, passing arguments or treating blocks like functions is definitely something it inherits. But in a lot of other ways, it's still an SSA style IR. So it's sort of this weird blend.
Yeah. But yeah, the live out and live in, it is like documented, not as well as it probably should be, but it is like documented in comments a little bit in the live values struct. It's in like AR, IR, algo, and then live.rs.
I basically just have been reading through the source code as sort of my reference, since it's mostly what I have to go on. So that one is in the lower utils stuff, right? Yeah.
So it's used in lower utils, but the actual like live value generation is defined in like live.rs and libair, libair, EAR, IR.
Okay.
So it's used by the lower utils, but it's like a separate thing that's used for a lot of other passes as well.
The live block graph.
So the algorithm itself is defined in algo and then live.rs.
Okay.
You can see that it's not documented very well, but it's like live at, live in before block arguments after. So that's at least like for a reminder. And you can also see some examples that are like in the tests, I guess. I don't know how helpful that is, but.
All right, yeah, I'll take a look here, and I think there's some code that I need to change a little bit and see if I am able to get what I need to get. If so, then maybe it's fine.
Like if there's anything at all.
As long as I have enough information when I'm generating the blocks.
Yes.
To, you know, set up the arguments and everything correctly, and then while I'm walking through a block generating code, know which arguments I need to forward to the next block.
You shouldn't.
That's all I need.
With the information, if I understand everything correctly, then you should be able to just like generate it by only looking at what you're at currently. You shouldn't have to look around.
Right. I think you're right.
But if there's anything like any questions or anything, then like this is pretty important. So I'll be like around to answer questions or whatever.
Yeah, I'll definitely send you a message as soon as I've gotten a chance to test this.
Even if there's anything, like instead of spending time like reading source code or anything, if it's quicker to just ask me, then feel free to do that.
Yeah, I'm basically at a point, I think, where I've gotten all I can get out of the source, so I'm mostly running up against things that just like are me not understanding how some of the things are used.
Yeah, this is all like big picture stuff that's difficult to find by reading the source code.
Right. All right. Well, I think you're right that that I have what I need, maybe with just the live sets. So if I get what I need out of that, then I think we're A-okay.
Yeah.
That was the only real obstacle I have. I think one of the things that tripped me up a little bit, just looking at the printed IR now, I'm having to sort of like dump a lot of the structures in memory as I'm walking over them to try and understand how what I see in the textual IR maps to like actual things.
Yeah.
Particularly because the textual IR is, I guess, a little bit different than like after the lowering analysis performed. You know what I mean? Like the stage at which I print the textual IR is after all the passes have been run, but before lowering.
Yeah, so lowering analysis doesn't change the IR, but there's like a better critical data there, and hopefully,
Yeah.
like with a rewrite I'm doing of the printer, it's really easy to add like annotations and like
Like
make
one of the
things
things it
clearer in the
does, for
IR.
example, is implicitly lifts some functions.
Yeah, and represents that. Yeah, so that with
Right.
the new printer, that should be really easy to just plug that in and annotate that in the
Yeah.
textual IR.
And I guess probably technically speaking, I could dump just the function IR. I don't need to dump the whole module, but in any case, like I got close enough for what I needed, but there, like looking at some of the function calls, there seems to be two different things. I want to make sure I understand how this is represented. So there's function calls, which are just like, you know, the function article with its immediate arguments. And then there's this form in the textual IR where it's also followed by like a fat arrow and then like
Yes.
thing except other thing. And the way
Yeah,
that's
so that
printed, I guess, is maybe where I'm getting tripped up. Like, what is that represented as?
it's just like the regular call.
Yeah.
So there's like two different in the can you hear me okay?
Yeah.
Yeah, okay. In the API, there is two kinds of call operations.
No,
there is
yeah, I know that there's the two different calls. Like I'm lowering those already.
Yeah, but I'm just saying like the control flow call that maps to the regular like without the fat arrow and everything.
Okay.
And the function call is maps to the one with the fat arrow and except. And it's just
so
like
that's where it forwards the return and escape a continuation.
Yeah, there's probably like a better way to represent that, but that's like I didn't want to have like a function call or something prefix. But if you have any suggestions on how to make that better, easier to read, then I'm open for it.
I think that's fine. The other alternative is to just treat them like regular plain arguments, since they already have sort of a special place anyways
But
in
it
IR as
does-
the first two arguments. But
It does need to have like an annotation that this is a function call and this other one is a control flow call because they're semantically different.
So I think the way maybe you can represent the control flow calls in the IR is just like a operation prefix, like a branch kind of thing, because that's really what they are. It's just a branch, right, with arguments.
Yeah.
And I guess maybe that would be one thing to consider here too, is that adding some additional sort of semantic operation information here. So in the case of a function call, it could just be call block argument args. In the case of a control flow call, it could just be branch destination block arguments.
Yeah.
And like you already do with match, right? Or if bool and things like that. You already have like sort of this operation prefix. If you in the textual IR, you did that for things like calls and control flow blocks or control flow calls, then it would be really easy to read it, sort of just because you get all the semantic information just as you're scanning
I fully
the
agree.
text.
I don't. That has actually tripped me up a couple of times to like missing the suffix and not catching that it's a like different type of call. So like changing that around is definitely like a good idea. Yeah.
I hadn't caught that the difference there was that one is a control flow. That makes sense now.
Yeah. So that and again, this I started writing some like proper documentation for this. Like all of this should be documented explicitly, but it's not at the state where it's properly helpful yet, I think.
Yeah, the other one that I wanted to make sure I am understanding correctly is the way that just with my simple module that I dumped here, there's one use of trace capture raw that takes a block as an argument. And the documentation I saw in libeir did not mention that it took any
That's
arguments.
That's just like the continuation, right? The block.
Right. I mean that that more or less I got, and I just want to make sure that I understand exactly what that represents, right? So I figured that it was sort of like here, jump here after you like capture the trace, right?
Yeah, so the block after takes like one implicit argument, which is the like captured trace, raw trace.
Right, and that's where I got tripped up, I guess, was that it takes that argument, and the part that I was unsure about is, so we have trace capture raw and trace construct, and what is the value supposed to be in the case of trace capture raw, because that's not going to be a value that we like generate necessarily. I guess we could theoretically allocate it on the global heap and pass a pointer as a value.
So that's a bit like it's sort of to decouple the implementation of how stack traces and stuff are handled from like the IR. That's the idea behind it. So the trace capture raw operation is called at the point where you actually need to take the stack trace, and then that's passed up through like the escapes for exceptions. And then if you actually need to use that value and like return it, pass it into Erlang, then the other, what was it, trace construct?
Yeah, trace construct.
Yeah, then that is called, because there are like many cases where you don't actually need to construct the stack trace, where it's just unused. So the idea is to like be able to represent that you don't need to actually construct the term form of the stack trace at this point. But I mean, if that's not needed, then like just like constructing the term.
No, I think it's fine. So with trace construct, in my example code here, I don't actually do anything with the exception that theoretically could be thrown. I think this is an automatically generated capture anyways. Does it then take this same value as an argument?
So trace construct, by definition, must take a value that is generated by trace capture raw. So the value returned by trace capture raw, the code gen can, I mean, at least the front end can never generate IR where something generated by trace capture raw is used in any other place than trace like construct.
Right. Yeah.
So that's sort of meant to be like sorry.
The way I think we're going to end up probably representing this is not actually passing a value around, but storing it as something that is part of the process. And then trace construct would be used as a signal to say, hey, actually construct the term representation of this stack trace that we've stored and give it to me. Because particularly when you have exceptions, like anything on the stack is going to be lost. So I guess our only real option would be to store like the captured thing on the heap somewhere and pass that pointer around, but even that pointer becomes a pain to pass around. So, shit. I just did all that talking. Oh no.
Paul, what's the matter? You're still on.
Yeah, but Hans isn't.
Oh, Hans.
That's how it goes.
No, you know what? Oh, Paul, it's actually recording.
Oh, all right. Well, that helps, I guess, but probably just have to suffer through repeating myself for the sake of convenience.
That's okay. We should probably stop it anyway. We're over an hour.
Yeah, no, I'm sorry you guys stuck around. You didn't really have to stick around.
Fine. I'm
for
just
all
gonna
this.
pause the recording.